Welcome back, everybody, for another deep dive. This time, we are taking a look at a research paper, and it's called Satori Reinforcement Learning with Chain of Action Thought Enhances LLM Reasoning via Autoregressive Search. Quite a mouthful, but we're going to break that down.
Yes, definitely a lot of jargon in there.
It's all about really pushing the boundaries of AI and how it can reason like us humans.
Yeah.
So, kind of a big deal.
Yeah, it's a very interesting problem that we're facing. We've come so far in AI, but teaching machines to kind of think step by step, like how we would figure out, a complex math equation or how we would plan a trip across the country,
Right.
things like that. It's a big challenge still.
It's not just like, oh, feed it a bunch of data and, hope for the best, right? What are some of the things that researchers have been hitting roadblocks on?
Yeah, exactly. Like the traditional ways of doing it, showing the AI just tons of examples or having humans guide it through every step of the way. Those kind of fall apart when you need that, multi-step reasoning.
Right.
Think about it. If you were learning to play chess and you just saw the final board conditions,
Right.
you wouldn't learn how to play chess like that.
Right.
You need to understand all the moves and the consequences along the way.
Right. So you need the steps in between, right?
Exactly, yeah.
So how does the Satori model change the game?
Yeah, so
I mean, even in the title, it mentions to show you about autoregressive search. I mean, that just sounds very technical.
yeah, it's a very clever technique. Think about it like you're solving a puzzle.
Okay.
You're not just trying one piece at random, right? You're kind of exploring different options mentally and you're seeing how they fit.
Right.
Satori does something similar where it can generate its own kind of potential solution steps and evaluate them internally and then choose the best path forward.
Wow. So it's like having a little brainstorming session in its own, AI brain.
Yeah, exactly. It can kind of plan ahead, which is what's so cool about it.
So it's not just following instructions, it's actually like thinking on its own.
Yeah.
Is this like a massive, resource-heavy AI?
That's what's even more impressive. It's only a 7 billion parameter model, which is actually relatively compact in the world of large language models.
Okay.
And they tested it on some pretty tough mathematical reasoning tasks, and it outperformed models that were trained with, way more data and way more human input.
Really?
Yeah.
That's pretty crazy. So does that mean it can only solve math problems?
No, not at all. One of the really exciting things about Satori is that it can generalize.
Oh, wow.
Yeah, so it can take those reasoning skills that it learned in math and apply them to other areas like common sense reasoning or even, tasks in chemistry.
Wow. So it's not just a one-trick pony.
No.
It's adaptable.
Yeah, very much so.
So what is the secret ingredient? What makes it so versatile?
Yeah, so it's something called the chain of action thought mechanism, or they call it COAT for short.
Okay.
It's basically like giving the AI a set of thinking tools. So it can do things like, reflect on its work and check for errors, or it can explore different approaches if something isn't working, or it can just continue on its current path if things are looking good.
Wow. So it's not just crunching numbers. It's actually thinking about how it's thinking.
Exactly. Yeah, that's what makes it so interesting. It's getting closer to more self-aware AI.
Right. So it's like metacognition, right? It's aware of its own thinking.
Yeah, exactly.
Wow. So how do you even train an AI to do that? I'm picturing, researchers huddled around a whiteboard, trying to, instill wisdom into this computer.
Right. It's a good image. Yeah, it's a two-stage process. So first, they actually use a small data set of expert-created examples to kind of teach Satori the COAT format, showing it the ropes. But then the really exciting part is the self-improvement part.
The self-improvement part, is it hit the gym and start journaling?
Well, not quite, but yeah, kind of a similar idea.
Okay.
So they use this technique called Restart and Explore, or RAE.
Okay.
And basically, instead of just, starting from scratch every time it makes a mistake,
Right.
it can restart from kind of where it went wrong and focus on correcting that specific error.
Okay.
And then the explore part encourages it to try different solutions even when it finds a correct one.
Oh, wow. So it's constantly pushing itself to be better.
Yeah, exactly. To find the best way and the most efficient way to solve things.
So it's becoming more accurate over time.
Exactly. Yeah.
That's incredible. So is there proof of this? Is this all just theoretical, or can you give us concrete examples?
Yeah, no, it's not just theoretical. The paper is filled with examples of Satori, catching its own errors in mathematical reasoning.
Okay.
Reevaluating its approach and even coming up with, more elegant solutions than the ones that the experts initially provided.
Oh, wow. So it's learning to outsmart even its creators in a way.
Yeah, in some way it's really impressive.
This all sounds so promising, but how does this model stack up against other AI models that are trying to, crack this reasoning code?
Yeah, so there are definitely some strong contenders out there, DeepSeek's R1 is another one that uses a combination of fine-tuning and reinforcement learning.
Okay.
But there are some key differences. First of all, Satori is completely transparent. It's open source.
Oh, nice.
So that means that the whole research community can, study how it works and identify potential biases and kind of contribute to its development.
Yeah, so it's more collaborative.
Yeah, exactly. Whereas R1 is kind of like, they keep it all secret.
Right. So it's like a recipe that you can tweak versus a prepackaged meal.
Exactly, yeah.
So, I mean, the open source thing is really important, for collaborations, for making sure that these things are developed responsibly.
For sure, yeah.
What about the size? I mean, is this a massive, model?
Yeah, so that's another big difference. Satori is actually significantly smaller than R1, but it achieves comparable or sometimes even better results.
Really?
So this kind of suggests that we might not always need these massive resource-intensive models to get, breakthrough performance.
So it's more efficient, too.
Exactly. Yeah.
Wow, this is all super exciting, but I'm really, ready to, see the rubber meet the road here.
Yeah.
Can you give us some specific examples of, how Satori is self-correcting, in action?
Yeah, for sure. So in part 2, we can delve into some compelling case studies from the research paper and really show you how Satori can, identify and correct errors, adapt its strategy, and even learn from its mistakes in ways that are, really similar to how humans would solve problems.
I can't wait. I'm really excited for that. So stay tuned, everyone. We'll be back with part 2 of this deep dive where we will explore these real-world implications of this amazing technology. Welcome back to our deep dive into the world of Satori. Last time we were talking about how it's really like pushing the boundaries of AI reasoning with this ability to self-correct and learn from its mistakes. And I'm really curious to see how this all plays out in practice. Can you walk us through some specific examples?
Absolutely, yeah. One of the examples that really stuck out to me that highlights Satori's self-correction ability is from a mathematical reasoning task.
Okay.
Imagine you're trying to solve for a specific variable in a complex equation.
Okay.
You're carefully going through each step, but then you make a tiny calculation error somewhere along the way.
Oh, man, I've been there.
Yeah, even a small mistake can throw off the whole problem, right?
Exactly, yeah. So how does Satori handle those moments?
So in this particular example, Satori actually caught its own error. Yeah, it triggered its what they call reflect meta action,
Okay.
which is essentially pausing to double check its work.
So it's it has built-in quality control.
Exactly. Yeah, pretty impressive.
That's really cool. So did it just stop there, or did it actually try to fix the mistake?
No, it went a step further. It pinpointed the error in its calculation, corrected it, and then continued on from there to reach the correct solution.
Wow, so it can identify its own errors and then actually fix them?
Exactly.
That's incredible. It's learning to be more meticulous than I am.
Yeah, it's pretty amazing. The researchers also tested Satori on problems that required more than just number crunching.
Okay.
They gave it a challenge from the AIM 2024 math competition,
Okay.
which is a problem that even seasoned mathematicians would find tricky.
Wow, so we're talking about real-world, high-level problem solving now.
Yeah, exactly.
So how did Satori approach this one?
So initially, it attempted a rather complicated approach involving a system of equations, which is a pretty standard way to tackle this kind of problem. But after a few steps, it seemed to realize that this path was becoming overly complex and increasing the chances of making errors.
So it was aware of its own limitations,
Exactly.
even as it was working through the problem.
Precisely. And that's when it triggered its reflect meta action again.
Okay.
Essentially taking a step back to kind of reevaluate its strategy.
It's it's having a conversation with itself wait a minute, am I doing this right?
Yeah, exactly. Okay, this is getting messy. Maybe there's a simpler, more elegant way to solve this.
Right.
And that's exactly what it did.
Oh, wow.
Yeah, it switched gas using its explore meta action to try a different strategy, breaking the problem down into smaller, more manageable chunks.
So it recognized that, sometimes a step back could lead to a leap forward.
Exactly, yeah.
Did this new approach work out better?
Absolutely. By simplifying the problem, Satori was able to solve it with fewer steps and with, a lower chance of making errors.
So it was more efficient.
More efficient, yeah.
That's really remarkable, how Satori really, mirrors human problem solving.
Yeah.
We often have to go through that same process of trial and error and refine our approach until we find, the most efficient path to a solution.
Yeah, that's a key point. The researchers highlight Satori's ability to self-reflect and self-explore is crucial for its ability to reason more like a human.
Okay.
It's not just mindlessly following a set of instructions. It's dynamically adapting and making decisions based on the context of the problem.
Right, so it's developing this kind of like intuition for problem solving,
Exactly, yeah.
which is fascinating, but we can't forget that Satori isn't just, a math whiz. It's shown promise in other areas like common sense reasoning as well, right?
Right. In one example, they gave Satori information about Christopher Reeve's spinal cord injury
Okay.
and then ask a question that required it to draw inferences, not just rely on the facts that were presented.
Okay, so it had to like, go beyond just logical deduction.
Exactly, yeah. Tap into like a deeper understanding of the situation.
So what was your question?
They asked if Christopher Reeve were poor, would he have lived?
Wow, that's a really heavy question.
Yeah, it is, and it touches on some complex societal issues.
Yeah, for sure. So how did Satori even approach that?
So initially, it made an assumption based on a common stereotype,
Okay.
reasoning that since Reeve treatment was expensive, he wouldn't have survived if he were poor.
Right, so it fell into that trap of oversimplification.
Yeah, which we as humans do all the time.
All the time, yeah. Did it just leave it at that?
No, that's where its self-reflection kicked in again.
Okay.
It seemed to recognize that its initial assumption was based on a generalization that might not always hold true.
So it's like it realized that it needed to think about other things too.
Yeah, exactly. Consider a wider range of possibilities, challenge its own biases.
Wow.
And so it explored other factors like the potential role of charitable organizations or government assistance that could have enabled Reeve to receive treatment regardless of his financial situation.
So it basically like, broadened its perspective.
It
And went beyond like that narrow view
precisely.
to consider like the nuances of the real world.
Exactly. This example shows how Satori's self-correction ability isn't just about catching math errors.
Right.
It's also about questioning assumption and considering alternative viewpoints, which are, crucial for navigating the complexities of human experience.
This is all so impressive. Like, it's really clear that Satori's self-correction capabilities go far beyond just fixing, simple mistakes.
Yeah.
It's learning to think more critically and creatively, which is super exciting.
Yeah.
But I'm also curious about the bigger picture here. What are the implications of this technology? Like, what does it mean for the future of AI if these models can learn to reason more like humans?
Yeah, that's the million-dollar question, isn't it? And it's one we'll definitely delve into in the final part of our deep dive.
Okay.
We'll explore how Satori stacks up against other cutting-edge reasoning AI systems and discuss the potential impact of this technology on various aspects of our lives.
I can't wait. I'm really excited for that. So stay tuned, everyone, for a final part of our Satori Deep Dive, where we will explore the future of reasoning AI and the exciting possibilities it holds. All right, so welcome back to the final part of our Satori Deep Dive. We've really explored the inner workings of this incredible AI, its ability to self-correct and even tackle those complex problems, kind of in a way that resembles how we think.
Yeah,
And now I'm kind of like eager to shift gears a little bit and
right.
talk about the so what of it all.
Right.
Like, what does this mean for the future? What does it mean for us?
Yeah, that's the question that keeps researchers up at night, and rightfully so. I mean, Satori isn't just some cool tech demo. It's a glimpse into a future where AI isn't just following our instructions,
Right.
It's actively like collaborating with us and bringing its own reasoning power to the table.
So it's less of a tool and more of a partner.
Yeah, exactly.
Wow. I mean, what kind of impact could that have on different fields? Like, I'm just trying to wrap my mind about that.
Yeah, so many errors. I mean, just think about like scientific research, for example.
Okay.
Imagine Satori-like models working alongside scientists, helping them analyze data spot patterns that we might miss,
Right.
Even propose new hypotheses. It could just accelerate breakthroughs in medicine materials, science, you name it.
It's almost like having this like superpowered research assistant,
Right.
but one that can think critically and creatively.
Exactly.
That's pretty wild. What about everyday life? How would this impact like the average person?
Yeah, think about like personalized education, AI tutors that can adapt to each student's learning style and provide, tailored explanations and even identify when a student's struggling with a concept.
Right.
Or even just imagine like AI assistants that can help us make more informed decisions like planning a vacation, managing our finances, or even like navigating complex choices.
I mean, it sounds so empowering. Having that kind of reasoning power at our fingertips could change how we approach so many things.
Yeah, it's definitely a paradigm shift. And, with any powerful technology, there are questions we need to consider as this field evolves.
Of course, making sure that these advancements are used ethically and responsibly.
Right.
What are some of the things that, researchers are doing to kind of make sure that happens?
One of the things that makes Satori so promising is that it's open source.
Right.
So the researchers have made its inner workings transparent so the wider AI community can study it, identify potential biases, and, contribute to its development.
So it's like that open approach is key to building that trust and making sure this technology benefits everyone?
Yeah, I think so.
Now, I know that Satori is not the only player in this AI reasoning game, right?
Oh, definitely not.
Like, what other models are out there kind of pushing the boundaries as well?
There are some fascinating contenders out there, each with their own strengths. DeepMind's AlphaZero, for instance, has become incredibly skilled at strategic thinking in games like chess and Go,
Yeah, I've heard of that.
showing us, the potential of AI for like complex planning and decision making.
And it was beating like the top players in the world, right?
It was, yeah, really impressive stuff. And then there's OpenAI's GPT-4, which you've probably encountered in some form,
Yeah.
known for its impressive language generation abilities, but it's also being explored for a wide range of reasoning tasks, from like writing code to composing music.
Wow. I mean, it seems like there's a real race to the top in this field.
Oh, yeah, definitely.
It makes you wonder what's going to be the next breakthrough.
It's hard to say, but, while each of these models has its own unique approach, they all share that common goal of unlocking the secrets of human-like reasoning and, replicating that in machines.
And the Satori has shown us that it's not just about raw computing power.
Yeah.
It's also about designing, these clever mechanisms like code and using those innovative training techniques to kind of foster self-awareness and adaptability.
Right. It's a really interdisciplinary field, blending computer science with cognitive science and even, a touch of philosophy.
That's awesome. Before we wrap up this incredible deep dive, I have one final kind of thought-provoking question for you. So the paper mentioned that Satori can kind of adapt its reasoning process based on the difficulty of the problem.
Right.
If it can do that, could we eventually train LLMs to like dynamically adjust their thinking style based on the task at hand?
That's a fantastic question, and it opens up a whole new realm of possibilities. Imagine LLMs that can switch between like logical deduction, intuitive leaps, even artistic inspiration, depending on the challenge they're facing.
It's like having an AI that can tap into like different modes of human intelligence, like a true Renaissance mind.
Exactly, be a game changer in how we collaborate with and utilize these powerful tools instead of being limited to one way of thinking. They could become these versatile partners, enhancing our own cognitive abilities in ways we can only imagine right now.
Well, on that note of wonder and possibility, we've reached the end of our Satori deep dive. A huge thank you to our expert for taking us on this incredible journey.
It's been my pleasure.
And to all of our listeners out there, we encourage you to explore this research further, share your thoughts and join the conversation about the future of reasoning AI. Until next time, keep those minds curious and those questions flowing.